Welcome to the series where we are discussing basics of machine learning. Here you are seeing an equation which you will see very repeatedly in the machine learning field, which is y is equal to mx plus c. So this basically represents a straight line. A line could be represented in terms of a slope and the y-intercept. In machine learning terms, we call x as the features, m as the weight matrix, and y as the output, right? So this simple line equation can determine how a machine learning algorithm can adapt to the feature weights and can predict the output using these features, right? So instead of just looking at this equation, we have a very interactive tool called Desmos where we can actually visualize what these M and C are all about. So we understand about the X and Y, but to understand more about M and C, we will use a interactive tool. We have this Desmos tool which is accessible by anyone.
You can play with these parameters, right? So you have the equation defined here, which is y is equal to mx plus c. Now you can play with the slide across this thing to see how the line changes for each change in value in c, right? This looks cool, right? So the way it is represented, that's what makes it easy for us to understand mathematically what happens when value of c is set to each of the specific values,
So
right?
what actually is changing? I see the line is getting changed.
Hmm.
Could we try the M as well? I want to see how it is changed. Oh wow.
Yeah, so you can simplify these two things in two words, right? C is nothing but the shift of the line, right? So you see the shift happening across the x-axis, right?
Hmm.
And M is nothing but it defines the angle of the line. So it's
Sure.
like it looks like a clock, right? You set it in a single space, and if you keep sliding it, it rotates your line.
Hmm.
So even in neural network terms, it's easy to simplify this, right? So in neural network, you would have come across weights and biases, right?
Yes.
So in this case, your intercept is nothing but the bias,
Sure.
right? And the weights are uh, can be compared with slope here.
Yeah. So when I change the slope M, the angle is going to change, and C determines how far I am from the origin, right? So let's see, why do we even have to rotate this with a simple example.
Sure.
So I have this example where I have two set of data points, one with the green point and other with the red point for simple assumption, right? And now let's reset this. Yeah. So now the task is I want to put a fine line which can separate these green points as one class and the red points as another class. So could you please demonstrate us how can we achieve this using these W vector?
Yeah. So this is simple, right? You just have to pull this line.
Yeah.
So you see this imaginary decision boundary separating these two clusters here, don't
Yes.
you? So you just have to pull that line such a way that it separates those two cohorts or groups clearly. Can you do it?
Um, Not really. I think we should get the help of W and W2. Could you please explain us what this equation actually means? Because I saw y is equal to mx plus c, but this looks little different.
Yeah, it's okay. So in the earlier version, right, it was a single feature wherein x was the only feature used, right?
Yes.
Now we got two different features, right, x and y, and the bias term which we saw as c is renamed as w naught, okay, and the m was the slope here, right? So that can be represented in matrix form as w1 w2,
Sure.
and x and y are your features here. So since it's a two-dimensional plot, you are using two different features here,
Yeah.
x and y.
Okay, then let me first start rotating it using the slope which is represented as W1 and W2. So let me rotate it. All right. Yeah. So now if I have to move it forward or backward, I mean the distance from the origin, let me play with the intercept, the bias factor. So let me rotate them again. See, it's too much of rotation, and it's not meaningful at all.
So first we have to fix the angle, right? So we have to play with W1 and W2 and make sure we get the right angle, right?
Yeah,
Yeah, I think
this
now it's
looks
perfect,
little
right? So now you can,
fine. Yeah. So, I think to even separate both of these, we played around with W and W2 and also W0 to put a fine boundary between green class and the red class. So, how could we relate this to machine learning now?
see, it's simple, right? So all these days we see this way of learning is completely different, right? So all these days we look into the equations and go to the model, see how the model works. But now just based on the picture makes it very clear, right? So in ML it's simple, whatever you have done, right?
Yes.
You tried out different combinations of W1, W2, W0. That's what the model does internally. As you can see, that's why you have a loss function which is like uh, you know our sixth sense, making us to create a decision boundary which
Right.
separates both these cohorts.
So, whatever I have done here by tuning these W weights, AI is going to do exactly the same. It's going to try different combinations of W and W2 and find out what is the right way to do it. And going forward, it would use that intelligence to predict about the future.
Yeah, so I would say it's model. It's not AI. AI is a system, right? So model is just a component in that. So this is what a model does basically.
Sure, so I'm so very excited by seeing this illustration.
Nice. Me too.
So, thank you very much for listening to this podcast. Stay tuned for more such simplifications on basics of ML.
Thank,
Thank you.
thank you.